Good morning, dear students. This is Dr. Praveen. Let we begin discussing electronic spectroscopy, which is one of the very much important portion of the chemistry syllabus for semester 6. As you know, the spectroscopy is one of the very much important branch of the chemistry, and as I said you that the spectroscopy all are physical. It is a physical method of investigation. The branch of chemistry, spectroscopy is the branch of chemistry in which the interaction of electromagnetic radiation with the matter brings about changes in the electronic energy level, and that changes in the electronic energy level is studied in the form of graph called a spectrum, and it is recorded by using a device which is called a spectrophotometer, and that device is called spectrophotometer. Now let me see what is UV visible spectroscopy. As all these स्पेक्ट्रोस्कोपिक मेथड लाइक यूवी विजिबल स्पेक्ट्रोस्कोपिक मेथड जैसे हमारे सिलेबस में है, इलेक्ट्रॉनिक स्पेक्ट्रोस्कोपी है, आईआर स्पेक्ट्रोस्कोपी है, एनएमआर स्पेक्ट्रोस्कोपी हमको स्टडी करने के लिए है, मास स्पेक्ट्रोमेट्री है, ये सभी स्पेक्ट्रोस्कोपिक मेथड का बेसिक फंडामेंटल प्रिंसिपल सेम है. Though they are different in their instrumentation, but the basic fundamental principle of all these spectroscopic methods is same, and that is absorption. Absorption is the basic fundamental principle of all these spectroscopy. So now what is this spectroscopy? When electromagnetic radiation or light irradiated with a molecule, that molecule absorbs the energy from the radiation and undergo changes in the energy level. Or you can also say that when a light radiation falls on the molecule, or when the light radiation is subjected to the organic molecule undergo excitation from lower energy level to higher energy level. That is nothing but changes in the energy level is observed, and that changes in the energy level is recorded as in the form of graph called a spectrum, and which is measured or recorded by using a device. That device is called spectrophotometer. So you can see here, this is the radiation source. When irradiated to a molecule, this is a molecule which contain what this is a sample holder which contain a molecule. So molecule is having different atoms, so there is absorption of this energy from this light radiation takes place. ये molecule ये light radiation में से energy absorb करेगा तो इसके energy level में changes हो जाएंगे. Or in another word, you can say molecule undergo excitation from lower energy level to higher energy level. So this molecule when undergo excitation from lower energy level to higher energy level, इसके energy level में changes होंगे, और ये energy level में changes होंगे जो एक ग्राफ के फॉर्म में रिकॉर्ड किया जाएगा. उस ग्राफ को हम स्पेक्ट्रम कहते हैं. उस ग्राफ को हम स्पेक्ट्रम कहते हैं, और ये जो स्पेक्ट्रम रिकॉर्ड करने के लिए हम जो डिवाइस यूज करते हैं उसे हम स्पेक्ट्रोफोटोमीटर कहते हैं. Isn't it? Spectrophotometer. So this is the simple principle of this UV visible spectroscopy. So why it is called as UV visible spectroscopy or electronic spectroscopy? क्योंकि हम यहाँ पे UV visible radiation source use करते हैं. The radiation source which we use in this spectroscopy is UV visible radiation. UV visible radiation is subjected to what the molecule, it undergo changes in the electronic energy level, and therefore what you will get a graph, or which is called as spectrum. Or in another word, it is also called as electronic spectroscopy. क्यों कहते हैं? Because this UV visible range of radiation irradiated to the molecule brings about changes in the electronic energy level. Molecule undergo excitation from lower electronic energy level to higher electronic energy level. इसलिए इसे इलेक्ट्रॉनिक स्पेक्ट्रोस्कोपी कहते हैं. इलेक्ट्रॉनिक एनर्जी लेवल में चेंजेस होते हैं, इसलिए इसे इलेक्ट्रॉनिक स्पेक्ट्रोस्कोपी कहते हैं. और इलेक्ट्रॉनिक एनर्जी लेवल में चेंजेस क्यों होते हैं? इट इज़ ड्यू टू व्हाट द यूवी विजिबल रेंज ऑफ रेडिएशन दैट वी हैव इरेडिएटेड टू द मॉलिक्यूल. Isn't it? So you do keep in mind that because of using UV visible radiation for irradiation to the molecule, it undergoes changes in the electronic energy level, and this is the graph which is also called as a spectrum, and that is due to what the changes in the energy level, electronic energy level, isn't it? And the device is called as spectrophotometer. So this is the simple principle of UV visible spectroscopy. Now let us look at this molecule. Now, in a simple molecule, it is a triatomic molecule. This is a central atom attached to two other atom, like anyone, you can say CO2 or any atom you can take. Here it is central atom, and here it is attached with the two atom. And this central atom attached with these two atom by a chemical bond which is not fixed or rigid. It is somehow, it is flexible. No bond is 100% rigid. It is somehow, it is a flexible, somehow it is flexible. So when this molecule is irradiated with the UV visible range of radiation, it is irradiated with the UV visible range of radiation, it undergo excitation. So what kind of excitation it undergo? When it irradiated with the electromagnetic radiation, the electron from this bond undergo excitation, means from lower electronic energy level to higher electronic energy level, and therefore electronic excitation is observed, isn't it? That means the electron of this bonded atom, electron of this bond undergo excitation from lower energy level to higher energy level, and therefore electronic excitation will take place. Vibrational excitation, this two atom, central atom and this one side atom, do vibrate each other, and when this is irradiated with this electromagnetic radiation, this vibration increases, and this vibration increases, it has some, more vibration or less vibration, it coming to the central atom and going away from the central atom, it increases or decreases. So therefore it has some vibrational excitation as well. So these two atoms do vibrate like this, so therefore it has vibrational excitation. Okay, and this atom which require very less energy for rotational excitation, it do rotate around about its own axis, so it has rotational excitation. So therefore when a molecule irradiated with the electromagnetic radiation, it undergo electronic excitation. So अब ये देखिए, सबसे ज़्यादा एनर्जी व्हेन दिस मॉलिक्यूल इरेडिएटेड विद दिस इलेक्ट्रोमैग्नेटिक रेडिएशन, सबसे ज़्यादा एनर्जी लगती है इलेक्ट्रॉनिक ट्रांजिशन के लिए, isn't it? Much energy is required or high energy is required for electronic transition, and very less energy is required for rotational excitation. So electronic energy level में हमको चेंजेस जो हो रहे हैं वो स्टडी करने के लिए हमको यूवी विजिबल रेंज ऑफ रेडिएशन देने पड़ेंगे, जिसकी एनर्जी बहुत ज़्यादा हाई है, उससे कम लगेगी रोटेशनल के लिए, वाइब्रेशनल के लिए. सो देयरफॉर whenever molecule irradiated with the UV visible range of radiation, it undergo rotational, vibrational and electronic excitation. Because electronic excitation के लिए एनर्जी बहुत ज़्यादा लगती है, उससे कम वाइब्रेशनल की लगती है, and then very much less for rotational excitation. So therefore the UV visible spectrum is little bit broader in nature, isn't it? Now you can see, as I have told you, that spectroscopy is nothing but the interaction of matter with the radiation. Matter with the radiation means, matter means a molecule, radiation means electromagnetic radiation, and you can also say that the response is given by the molecule when it is irradiated with the electromagnetic radiation, and that response is recorded with the help of device called a spectrophotometer. Now let me see that spectrophotometer is a device which record the changes when a molecule irradiated with the electromagnetic radiation. So what is electromagnetic radiation? इलेक्ट्रोमैग्नेटिक रेडिएशन क्या है, ये हमें देखना चाहिए. और जो एब्सॉर्प्शन ऑफ डिफरेंट टाइप्स ऑफ रेडिएशन जो होंगे मॉलिक्यूल से, such as UV visible, infrared, microwave, radio wave, produces different kind of excitation in the molecule, and each excitation provides useful information about the structure in the form of graph called spectrum. So what is this electromagnetic radiation? This electromagnetic radiation is one kind of energy that we are providing to the molecule. जब हम मॉलिक्यूल को इलेक्ट्रोमैग्नेटिक रेडिएशन या फिर लाइट दे रहे हैं, इट इज़ वन काइंड ऑफ एनर्जी associated with electric field as well as magnetic field. This is the direction of what the light, propagation of light, and this is what the propagation of the light or the direction of light. What you can have here, it is, अब ये जो perpendicular region है, perpendicular, this is what, this blue colored portion is the electric field, isn't it? Electric field. And this is what the black color portion it is, or pink color portion it is, this is magnetic field. And you can say that this electromagnetic radiation is associated with the electric field, blue color portion as well as the magnetic field, both are perpendicular to each other, isn't it? This electromagnetic radiation associated with the electric field as well as magnetic field, both are perpendicular to each other. And when this electromagnetic radiation interact with the molecule, this electric field, either electric field or magnetic field, interact with the molecule and produces change in the energy level. This blue portion will interact with the molecule, either or this pink portion, and therefore there is changes, brings about changes in the energy level, isn't it? So interaction of, what you can say, that the electromagnetic radiation with the molecule, that means the electric field of electromagnetic radiation with the molecule or magnetic field of electromagnetic radiation with the molecule. You have to keep in mind that this is the electromagnetic radiation, or it is a kind of energy associated with the electric field and magnetic field, both are perpendicular to each other, isn't it? And see, you can see now the different terms which involved in the UV visible spectroscopy, isn't it? Now the first one is wavelength. Wavelength is nothing but the distance traveled by the two successive crest or trough. That means this is the crest, isn't it? Two successive crests, the distance traveled by the wave in two successive crest or two successive trough. So this is called wavelength, isn't it? And wavelength is, as you all know, E is equals to h nu. Energy is directly proportional to the frequency of the radiation, isn't it? So therefore energy is inversely proportional to the wavelength, because E is equals to hc by lambda, hc by lambda, because nu is equals to c by lambda, nu is equals to c by lambda. Therefore frequency and wavelength are inversely proportional to each other, energy and wavelength are inversely proportional to each other, and frequency and energy are directly proportional to each other. You have to keep in mind that. Now wavelength measured in the number of units like angstrom, nanometer and micron. 1 angstrom is equals to the 10 to the power minus 8 centimeter, or which is equals to the 10 to the power minus 10 meter, that you know. Here it is, this is the two successive crest, and here it is the length of the wave. It is nothing but the wavelength, two successive crest or two successive trough, isn't it? 1 nanometer is equals to 10 to the power minus 7 centimeter, or 10 to the power minus 9 meter. 1 micron is equals to 10 to the power minus 4 centimeter, or 10 to the power minus 6 meter. Now let me see the second term, frequency. The number of rotation of wave in 1 second. The number of rotation of wave in 1 second, which is measured in hertz, called as frequency. Frequency is nothing but c by lambda, and energy is directly proportional to the frequency of radiation. You can see here frequency is measured in hertz. So this is what one oscillation, frequency is the number of oscillation per second. So this is what the wave, number of wave or one oscillation in 1 second is nothing but the frequency. This is the frequency, number of rotation of wave in 1 second, which is measured in hertz. So 1 hertz is equals to 1 cycle per second. 1 kilohertz is 10 to the power minus 3 hertz. 1 megahertz is 10 to the power minus 6 hertz. Now let me see energy. Energy is nothing but E is equals to h nu, which is directly proportional to the frequency of radiation and inversely proportional to the wavelength. So energy can be calculated by using this formula, that E is equals to hc by lambda, hc by lambda. Now energy is measured in joule. 1 joule is equals to 10 to the power 7 earths, isn't it? Now wave number. Wave number is the reciprocal of wavelength, and it is measured in Kaiser. 1 Kaiser is equals to 1 centimeter inverse. 1 centimeter inverse. Now what is amplitude? Amplitude is nothing but the height of wave related to its rest position. And now this is the wave, this is its rest position, and this height of the wave is nothing but the amplitude, or which is also called as power. The amplitude is the height of the wave related to its rest position. So this is the amplitude of the wave. So these are the some important terms which we have to study in UV visible spectroscopy or electronic spectroscopy. Now you can see the electromagnetic spectrum. Here it is UV visible region. Now electronic spectroscopy is also called as UV visible spectroscopy, because the, as I have told you, मॉलिक्यूल के साथ इलेक्ट्रोमैग्नेटिक रेडिएशन इंटरैक्ट करेगा, दैट मीन्स यूवी विजिबल रेंज ऑफ रेडिएशन। ये जो यूवी विजिबल रेंज ऑफ रेडिएशन है, ये रेंज के रेडिएशन मॉलिक्यूल के साथ इंटरैक्ट करेंगे एंड वी विल गेट व्हाट, द चेंजेस इन द इलेक्ट्रॉनिक एनर्जी लेवल। सो व्हाट इज दैट, 10 to the power 1 to 10 to the power 3, 3, isn't it? 10 to the power 1 to 10 to the power 3 nanometer. Wavelength increases from X-ray, UV visible, IR and radio waves. From left to right, wavelength increases. From left to right, frequency decreases. Wavelength increases, frequency, see, you can see here, from left to right, wavelength increases, and from right to left, frequency increases. So therefore, this is the UV visible range of radiation, and this portion or this range of radiation radiated with the molecule. Now this range brings about changes in the electronic energy level. So this is ultraviolet region and this is a visible region that we can see here. Expanded region, it is 400 to 750 nanometer of wavelength. Wavelength is increases from violet to red. Violet to red, wavelength increases. Wavelength increases, frequency decreases. You have to keep in mind that in UV visible region, 400 nanometer to 750 nanometer. And what is the color spectrum? Here it is. The spectrum shows from violet to red, wavelength increases, and red to violet, frequency increases. Frequency increases. So you have to keep in mind that, isn't it? Now spectroscopy is nothing but the interaction of matter with the radiation, as I have told you. Now how does the spectrum obtain, isn't it? And UV visible spectrum is nothing but the graph of absorbance versus the wavelength. So here it is the absorbance on y-axis, wavelength on x-axis. If the radiation of UV visible are used, then the electronic transition or electronic excitation takes place. Along with that, vibrational and rotational excitation also takes place, and you can see here it is broader nature of peak of UV visible spectrum, isn't it? Because UV visible radiation requires high energy than the vibrational and rotational. Therefore, along with the electronic, rotational and vibrational energy level may be changed only, isn't it? So this is what the UV visible spectrum. Here it is absorbance increases, yes, here it is absorbance, and here it is on x-axis, here it is wavelength in nanometer, isn't it? So therefore UV visible spectrum is nothing but this peak is obtained by the excitation of all in electronic excitation, vibrational excitation and rotational excitation, isn't it?